So in this case, we've gone through resultant vectors. Now we're going to have a look at vector components. So say, for example, what happens when they give you a vector like this? So we'll say it's 300 newtons, we'll stick with force. And they'll tell you it's an angle of 20 degrees like that. So what if they just leave you with that? And then they ask you to find the horizontal and vertical components of this vector. So last time we were finding the resultant vector when we had two vectors there drawn in, and we were finding the resultant of them. Whereas this case, they've given you the resultant vector and they want you to find the horizontal and the vertical components of it. So it's really just working backwards. So if we draw this in, so I'll draw my horizontal component in green and I'll call it X. So that's my horizontal component, and then I'll draw my vertical component in red and I'll call it Y. It's the vertical. And we have to find those. So we'll form a right angle triangle again. And bear in mind that this here has the same magnitude as Y. And this here has the same magnitude as X, our vertical component, even though I didn't draw it very well there. And we'll use our trigonometric functions again. So in this case, you have to work with the angle and the hypotenuse, so which is 300 newtons, or your real resultant vector. So let's find X first. So we know that, we know that cos of 20 is equal to the adjacent side, which would be your horizontal component, that's X, over the hypotenuse, which is 300. So therefore we can say that 300 times cos of 20 is equal to X, our horizontal component. So that means that 300 times cos of 20, that's 281.9 newtons. Alright, now let's find the vertical one. So again, we have to use a trigonometric function. So we know that sine of 20 is going to give us the opposite, which would be our vertical component, over the hypotenuse of the triangle. So that is the 300 there. And that means that 300 sine of 20 will leave me with my vertical component. So Y then is equal to 300 times sine of 20, and that's 102.6 newtons. And there is your answer. That's your horizontal component of the force and your vertical component of the force. And just when you're doing these as well, if, say for example, when you're breaking it down to components and you get something bigger than the original resultant, you've gone wrong somewhere. Okay, they should both be smaller than it. All right, let's have a look at maybe some more, well, not real life situations. I don't think you'll ever be asked to calculate this in real life, but let's apply it to something. So we have here a stone of weight 60 newtons rests on a sloped roof. The roof is inclined at 30 degrees to the horizontal. Resolve the weight of the stone into components parallel and perpendicular to the roof. All right, first things first, we need a diagram. So I'll draw in my roof like this, because they say it's sloped and it's at 30 degrees, sorry, to the horizontal. And they tell me my stone is at rest, so it's not moving, so it's just sitting on the roof up there. And its weight is 60 newtons. So its weight is going to go directly down like this. And I'll mark in 60 newtons like that. So that's its weight. And lastly, they want us to resolve this weight into two components again, but instead of horizontal and vertical, they're asking us for parallel and perpendicular to the roof. So it's about perspective here. So let's see, so I'll do my parallel component in blue maybe, and then I'll do my perpendicular one in green. Right, let's start with perpendicular because that's a handier one. So perpendicular always means at 90 degrees. So it makes a right angle with the roof. So that would be at about here, like that. So see there, I have a right angle with my roof in my parallel component. Or sorry, my perpendicular component, that one is. Then parallel means to have the same slope. So in this case, the angle with the roof would be, I suppose it would be 0 or 180 in that case. So that would be in line with the roof like this. Right, and I'm very bad at drawing these, so I'll end it about there. And that's my parallel component. So I'm going to write my parallel component as weight with two lines here, so they represent parallel. And I'll put this one as weight with perpendicular line, so a little perpendicular subscript. And now we have to find the values of these. So we'll start as we normally do, and we'll make up our, I might do this in red actually, we'll make up our little rectangle as normal. So there it is there. And you'll notice that this here is a right angle. And you'll also notice again that the magnitude of this here is the same as the parallel component. And likewise, the magnitude from here to here is the same as the perpendicular because it's a rectangle. And now we need to incorporate this angle in somewhere. So you'll notice if we have a look at this triangle here, this right angle triangle between the stone and the roof, that this is a right angle triangle, or a right angle in here. Okay, it makes 90 degrees. And we know that there's 180 degrees in a triangle. So that means that this last angle here must be 60 degrees. Okay, because 30 and 60 will give me 90, and 90 will give me 180 degrees. And we also said that this is at a right angle with the roof, this perpendicular component. So that means that this also makes up a right angle triangle. So this must be 30 degrees in here because the sum of these must be 90. And now we have an angle we can work with to work out our parallel and our perpendicular components. So let's start off with the parallel component. And we'll say, so we know that sine of 30 degrees is equal to the opposite side, which is our parallel component, over the hypotenuse, which is 60. So that means that 60 times sine of 30 is equal to our parallel component of our weight. And 60 times sine 30 is 30 newtons. Okay, and now let's have a look at our perpendicular component. So we know that cos of 30 is equal to the adjacent side, which is our perpendicular component, divided by the hypotenuse, which is 60. So that means that 60 times cos of 30 is equal to our perpendicular component. So our perpendicular component then is 60 times cos of 30. Right, so it's given it to me as 30 root 3. So we can simplify that to 51.96. 51.96 newtons. And then we just solved it into our parallel and perpendicular components up there. So in terms of these ones, we don't need, well, we have already stated a direction because we've said that it's the parallel component in regards to the roof, or parallel to the roof, and this is the perpendicular component, so it's perpendicular to the roof. So we've given them directions and we've shown them on the diagram, and now we've just found the magnitude of them. And you'll notice again that neither of them are bigger than the actual weight of the stone, which is 60 newtons. All right, let's have a look at one more, this time involving a pendulum. So at a certain instant, a pendulum is inclined at 50 degrees to the vertical, and the weight of the pendulum bob is 300 newtons. Resolve this weight into components parallel and perpendicular to the pendulum. Okay, so let's have a look. First of all, I'm just going to take out this little box here. So a pendulum is something that hangs like this. You sometimes see them in like old grandfather clocks, and they swing left and right. So in our diagram, so that's when it's at rest. In our diagram, at this certain instant, this is the vertical here, and they've told us that it's at 50 degrees to the vertical, like that. And the weight is 300 newtons. So the weight goes straight down. So that means our 300 newtons goes down like that. And that's our diagram set up. And then they want us to resolve the weight of this pendulum bob into components parallel and perpendicular to the pendulum. Okay. So let's have a look. So I did parallel in blue last time, so I'll keep that. So I'll keep parallel as blue and perpendicular as green. Okay, let's have a look at parallel. So remember, we said parallel was the same slope, and we want to make a right angle triangle with this weight of 300 newtons. So parallel will be going the same direction, so it will be going this way, like that. So I'll call that the parallel weight. And then perpendicular is at a right angle. So if I take it from, let's say here, and go down this way, that'll be my perpendicular weight. So I'm just going to finish off my triangle by joining them all up in here. Okay, so as you can see here, that's right angle, so I know that's right with my perpendicular weight. And this is parallel because they have the same slope, right? And then I have to make up my little rectangle again using my parallelogram rule. So that means that this in here is a right angle. Okay, so we have our components, and we know, for example, that this is the same magnitude as the parallel, and likewise this is the same magnitude as the perpendicular. So I have my right angle triangle, and all I need now is an angle other than the 90-degree angle, so I can start working out my two components. So the only thing we have to work off is this 50-degree angle. So you'll notice that this line we said was the vertical, and likewise the weight goes down vertical. And this parallel component has the same slope as this, well, the string of our pendulum. So that means that this angle in here must be 50 degrees. And now we can start working it out. So let's have a look at the parallel component first. I'll do that over here. So we know that cos of 50 is equal to the adjacent side, which is our parallel component, over our hypotenuse, which is 300 newtons. So that means 300 cos of 50 is equal to our parallel component. And that means our parallel component is 192.84 newtons. And now for our perpendicular. So we know that sine of 50 is the opposite, which is our parallel component, or sorry, our perpendicular component, divided by the hypotenuse, which is 300. So that means 300 times sine of 50 is equal to our perpendicular component. And that works out to be 229.81 newtons. And there we have it. So that is the parallel component of weight to the pendulum, and that is the perpendicular component of weight to the pendulum. And there you have it.